All right, ladies and gentlemen, it's Crazy G here again, and he is going to help you do some more factoring of trinomials that are out there. I mean, whatever teacher gave me day number 7 probably was this day 6 person right here who only had to do like 10 problems. And now we've got, day 7 where we've got problem after problem after problem. Okay, so here's what I'm going to basically say when it comes down to trinomials and factoring them in general. The one thing you need to have is you need to have a plan, all right? And the question is, do you know what kind of plan you're going to be employing when you do these kind of questions? So here's what I would suggest you think about when you're actually doing any kinds of trinomials. You've got to make decisions on what kind of thing you're looking at. So I would kind of go through this list of possibilities of what you've got to try. So here's the things to try first. First off, if I was dealing with any kind of factoring, I would look to see if any of the problems have a GCF right out of the gate. If there is something that can come out of all of them, take it out. It's really a good idea to take out a common factor if you have one. Now, that doesn't happen all the time, but when it does, it's well worth your time. Number 2 is trying to make a decision whether or not you're dealing with an easy trinomial or whether or not you're dealing with a hard trinomial. Now, the way you look at that is you look at the x squared term and what's in front of it. If it happens to be a 1 in the front, we're going to go down easy road. If it's not a 1 in the front, we're going to go down the hard trinomial road. So you're going to look at that x squared term, and you're going to look in front of it, and if it's any other number other than 1 in the front, it's going to be a hard trinomial. And we ultimately have to, in both of these two cases, we have to look at the x factor. Now remember that the multiplier is what goes on the top, and what it adds to is down here on the bottom. Now we're going to get a lot of practice at this, so we're going to make sure that we get the idea, okay? And then last but not least, the last little thing that I would suggest down here at the bottom is sometimes if it doesn't fit into any of those 3 categories, then you may not be able to actually factor. And you put here, it does not factor, doesn't factor at this point in time. And then you're just like, okay, I don't know what I have to do there. It doesn't factor, and it's therefore prime is what we're going to call it when it's actually not factorable. Now, before I even tackle any one of these single problems that are listed here, I want you to have a plan of what's going on. So we're going to look through these ideas right here, and we're going to make a plan for each individual one. So if I look at the 3 pieces of number 1, I don't see anything that's going to be able to come out of all of them, so GCF's out of the deal. It's a number 1 in the front, so maybe I'm thinking maybe this one might be an easy one. So I'm going to put like a question mark. Is that maybe an easy? We'll find out. Here's another one. 1, 2, 3 items. Nothing's coming out of all of those. There's a 1 in the front. Maybe that's an easy one. Okay, so I'm just giving you a possible ideas of where you're going to be at. This one's out of order. Maybe we'll put the word order right there. Maybe that might help us figure out what to do there. Letter A down here at the bottom. That's got a number 1 in the front. If nothing's coming out, that might be an easy one. So it looks like we got a lot of these easy trinomial ones that we've got to look at. A number 1 in the front, again, possibly an easy one. So we'll figure out what to do there. Letter C, nothing coming out, no GCFs. That's possibly an easy one. All right, so just having an idea of what you're going to try to accomplish is going to be super key to these. Now, it looks to me like most of these are what I would refer to as easy trinomials. Okay, if you're going to do an easy trinomial, you are definitely headed down the big X road. And it's about what it multiplies to, which is the back number. It's got to multiply to 2, but it's got to add to 8. Now remember that this is what it's got to multiply to, and this is what it's got to add to. So I'm thinking of 2 numbers that multiply to 2, but add to 8. Now wait a second, that doesn't even seem possible. Am I going to be able to find 2 numbers that even multiply to 2? They're like 2 and 1 or 1 and 2. There's no way that's going to make 8. So if it can't be come up with two individual numbers, then we would just go right to the bottom of this list and say that that answer is prime. It doesn't factor. There's no way you can come up with multiples for that. All right, this is an easy road question. Multiplies to 12, so that's what it's got to multiply to, but it's got to add to -7. All right, now we got to start thinking of numbers that multiply to the number 12. And sometimes when we get stuck and can't think of multiples, we have to maybe make a list. What kind of things multiply to 12? I've got 12 and 1. I've got 6 and 2. There's no way these concepts actually make the number 7, but there is -3, or there's 3 and 4. Now that is a 7 combination, but there's no way those add to -7, so they better both be negative. And in an easy one, the reason why we refer to it as an easy is as soon as we come up with the combination, which is a -3 and a -4, it goes right into the bubbles. That's why they're easy. Once you find them, bubble them up. X minus 3 and X minus 4 should be your possible answer. And that's what it factors to. Ta-da! You're done. That's why they're easy varieties. Okay, number 3. Ooh, the order. That's what I wrote down there. Maybe we should put the squared term first, and then the middle guy, and then this guy at the end. So a squared minus 43a plus 42. Just moving around some ideas to get them going the right day. Oh, that's a 1 in the front. That must be an easy one. Multiplies to 42, adds to -43. Let's make a little list here. What multiplies 42? 6 and 7? That ain't going to make 43. I think it's 42 and 1. Yes, awesome. But they've got to add to -43. They are both negative. So always keep in mind, you're talking about a negative times a negative, and these are my easy combination. And if it's an easy, cha-ching, bada bing, baby. We've got our answer here of x, a minus 42 and a minus 1. And that is its complete factorization, all right? So keep in mind, your goal here is know what you're talking about and get through it. All right, let's see. Oh, it said that it was an easy because it was a 1 in the front. Multiplies to 12, but adds to 4. Now, you might have to make a little list. 12, ooh, that's a really big. Ooh, yuck. I don't like that picture. Let's talk 12 times 1. That's going to make 13. 6 times 2, that's going to make 8. 4 times 3, that's going to make 7. Wait a second, I think those are all the factors of 12. Cha-ching, cha-ching. I don't know what's going to add to 4. It doesn't look like it works. So the bottom of that list must mean that it is prime at this point in time. So there's no way for us to factor that guy. All right? So go through your list. Take something out if you can. Then decide if it's an easy or a hard trinomial. 1 in the front again must be an easy. Multiplies to -72, but adds to 1. Now that 1 coming right here from the center guy. Remember, that's the top. This is the middle. This is the bottom. Multiplies to -72. Well, that's a 9 times an 8. But that's got a difference of 1. Ooh, now wait a second. 1's got to be positive. 1's got to be negative. So it must be a combination of 9 times -8. Multiplies to that. Adds to this. And since it's an easy, they go right directly in. Ax plus 9, x minus 8. Okay? Now the cool part about this is remember that if you end up putting down an answer, you should never get a single one wrong. If you decide to double distribute the question and do stuff that we learned on those first couple of days, it should definitely go back to the original question and get the original answer. Now, I shouldn't have put x's. I should have put that those were a's. So try and keep your variable correct, too, as well. So a plus 9 and a minus 8. All right? So make sure you're doing it the easy way. Letter C down here on the end. Is it an easy? Can't take anything out. GCF. Multiples of -24 that make -5. Now, it's got to be a positive and negative, so I wonder what kind of number we got here. multiplies to 24. That's a 12 and a 2. There's no way that's making 5. And I think we've got a 6 and a 4. That's going to either make a 10 or a 2. That ain't going to work. How about an 8 and a 3? Rock and roll. There's my combination that makes 5. It's got to be an 8 and a 3, but it's got to multiply to that, but add to, oh, that's got to be negative. Easy combination. Put your bubbles in and write your pieces in there. That's why we call them easy, guys, because as soon as the x is done, the variables, it goes right directly in. And look at that, I did it again. It's not about x's. I must have this fascination with x. It's about y. There we go. Make sure we get the correct combination in there. Okay? Now, all those first 6 were all about trying to make a decision on what you should do before you actually do it. So have a plan. Let's take a look at these next 6 that are listed right here. Remember, GCF is your first concept. You're looking for GCFs first, then you're thinking easy, then you're thinking hard, then you're thinking prime. So this is kind of like our list of what we go through to try and figure them out. Now, two-termers are dead giveaways that there might be stuff that can be yanked out of this guy. That's a GCF concept right there. This one, even though it has lots of letters, maybe I could take out an X, but there's not an X in this guy. Maybe I could take out a Y, but there's no Y in that one. So ultimately, I think maybe since the coefficient is 1 in the front, this might be an easy. All right, so I'm going to put a question mark there. Ooh, number in the front is a 1. Maybe it's an easy trinomial. So we'll find out in a second. Next one, it's a number of 1 in the front. Maybe it's an easy. Don't see any common number. Don't see any common number. Oh, it's a 1 in the front. Must be an easy. We got a whole bunch of easy ones. So this must be an easy assignment. And then this has got a 1, nothing coming out. That must be an easy. Okay? When you see your problems, here's what I'd suggest. Go through and find out what's your best technique before you even go for it and have a plan. What can I take out? I put GCF on this guy. What can I take out of these two ideas? Well, I definitely can see a Z can come out of them. And the number 6 and the number 21 are both divisible by 3. So if I took the number 3 out of each one of those, what would I get as the output results? If I took a 3 out of that, I'd get 2. And a Z out of that, I'd be left with a Z. If I took a 3 out of this one, I'd be left with -7, and the Z got taken out. Guys, that is factored. That's as far as it can go. Just as much. As soon as you accomplish your GCF and the square disappears, you're all done. Okay? Now, I looked at this one. It said that it was an easy. Now, that's different than anything I've ever seen, but I think the X might be the number 27. Got to multiply to that, but it's got to add to -12. Now, we'll deal with this y squared here in just a second, so I'll show you what to do with that. Let's make our list of numbers that multiply to 27. I don't know. What do we got there? 3 times 9? Ooh, that makes 12. And it must be a negative and a negative that might get that done. A negative times a negative makes a positive, but adds to a negative. Remember, this is what it's got to add to. This is what it's got to multiply to. Now, since it's an easy, it would normally be just straight up x minus 3 and x minus 9. But that doesn't take in consideration this y part. If you get a y squared down here on the end, it just goes on the end of each one of the bubbles. Because if I did my double distribution, you'd see the positive 21y right there, and the insides would give you xy and xy. So if you see a y squared on the end, you're just going to break it on the end of your bubbles. That'll get the job done, all right? Number 6, ooh, thought it was an easy. Multiplies to -54, adds to 15. Now, I can't emphasize enough that you guys need to know your multiples of things off your multiplication chart. So what makes -54? 2 times 27? I don't think that's going to make 15. And what else do we got? 6 times 9? 6 times 9, ooh, that's 6 times 9 is 54, and that adds to 15. So it must be a negative 6 and a negative 9. Ooh, that's not right. That's not going to work. It's got to be a add together to make negative 15, but multiply to negative 54. Now, I did that on purpose so that you would see that sometimes people pick things and they're just like, they pick the wrong thing and don't really pay attention to it. Now, what else makes negative 54? And if you're really struggling with like coming up with other factors, you can actually do what I call steal. And what I mean by steal is I got 2 and 27. Those two numbers work out. So if you could steal from one, you can add to the other. So like if I steal a 3 out of this one, and I divided this one by 3, I'd get the number 9. But if I multiplied this one by 3, I get the number 6. And that automatically makes 54. Now you can steal other things too. Like what if I stole out of this one, I stole the 3, and I multiplied, no, that would just take me back. What if I stole a 2? What if I divided this one by 2 and multiplied this one by 2? That would be 3, and it would be 18. And that's another multiple. Oh, check it out. That might be the one I need. A 3 and an 18. So that would be a positive 18 and a negative 3, and that adds to negative 15. It's an easy, so it must be x plus 18 and x minus 3. I cannot emphasize enough how important it is that this combination that you come up with is the correct combination. Don't just pick the first thing that comes to mind. Make sure that it completes the multiplication and the addition. Last couple ones we got. Ooh, that was an easy over there. Let's see if it is easy. This is going to end up being, let's see here. Turn it over to you. This is going to end up multiplying to negative 12, but adds to negative 1. Multiples of negative 12. 3 times 4. Ooh, that difference right there has 1. So it must be negative 4 and positive 3. And that would be just an easy one. X minus 4, x plus 3. Good job. Okay? And the only way to really keep getting good at these is practice. You just got to keep doing them over and over and over again till you really feel like you got the premise understood. Multiplies to negative 6, adds to 5. What kind of numbers am I talking about here? Now, this is another great example of people who pick the wrong things. It's got to multiply to that, so negative 2, I'm just going to put 2 and 3. Now, those two right there, they do multiply to 6, and they do add possibly to 5. Now, if you just throw those in there, you're like, I've got to multiply to negative 6. Maybe those is 1, negative 3, and positive 2, like that. And you're like, ooh, that does multiply to that, but that's the wrong combination that adds to 5. So don't just go with something that you know is going to be a factor, but make sure that it completes the idea inside your x. Another option would be 6 and 1. And if I chose to do 6 and 1, like 6 times 1, then it would make sense that I'm thinking that it might be 6 and negative 1. Now, those multiply to this, but they add to that. Make sure that you're getting the right combo. And since it's an easy, x plus 6 and x minus 1. So be sure that your x makes sense, because if you do, you'll get your factors right every time. Okay, now here's another one. Multiplies to 6, because that's from the back number, and the middle number has got to add to negative 5. Now I think this one might be a combination of a negative 2 and a negative 3. Multiplies to that, adds to this. So get them right, and you make sure that your combination is the one that you want, okay? That's super, super important. How many times over how many years I've been teaching, I see students who just throw values in there, and they don't really pay attention to seeing if it completes the actual x. Now, letter G, I'm trying to go as quick as I can here. Must be an easy, my favorite letter, G, okay? Multiplies to negative 30, adds to negative 13. What kind of numbers could that possibly be? Now, your first guesses might be like 6 and 5. There's no way that makes 13. It might be 2 and 15. Now, wait a second. That could possibly make a 13. I like that one. See, I always look at their sums and their differences to see what they come out with. And I think maybe that's negative 15 and then positive 2. They multiply to a negative. They add to a negative. Awesome. It's an easy x minus 15 and x plus 2. Okay? Solid. You're doing great. No GCF coming out of that guy. Must be a easy one. All right, you're like thinking easy. Okay, must be easy. It's got a 1 in the front. This is negative 13. Multiplies to that, adds to this. Let's see here. 3 times 10? 3 times 10 is 30, but it's got to be a negative 13. So maybe it's a negative times a negative. And that is a combination that adds to negative 13. Here we go. Easy. X minus 3 and x minus 10. All right, now, everything we've done up till there has all these easies, because the number has been a 1 in the front. Here we go. We're going to throw a little wrench in there. Now, when you do one that has a number in the front, you first check the GCF, nothing coming out. You can't say that it's an easy. This guy is a hard trinomial. Now, I don't want to say, I hate saying the word hard trinomial. They're not really difficult, but what the process involves is you got to do an extra couple of steps. And the first thing you have to do is get your x right. And the x right means that you multiply the front times the back, and that is what it has to multiply to. That's what goes up here. It's not just the 12 that drops in. It's 3 times 12, or 36. And this guy here in the middle is still the number that goes down at the bottom. Now, that's the first thing that's different in a hard trinomial. The next thing you got to think about is about getting the actual values like you've been doing in all the easy ones before, and you got multiples of 36 that add to negative 13. I think that's negative 9 and negative 4. Negative times a negative is a positive. They add to negative 13. Now, this is the most common mistake right here in the hard trinomials. People can get the front times back thing and get their x going. This does not go directly into a set of bubbles. It has a step in between, and that's what makes it a hard trinomial. This is going to be 3x squared. That comes from right here at the beginning. Then you put these two in the middle, minus 9x minus 4x. That's going to stand in place of this negative 13. And then you put the guy down here on the end, which is plus 12. This involves a technique that you guys learned on the previous day called grouping. Split it in half and tell me what you could take out of each one. If I take out a 3 out of each one of those, I get 3x. I can take out a 3x. I get x minus 3. And out of this one, I could take out a maximum of negative 4. And if it is negative right here, take the negative out with it, and that'd be x minus 3. Now, you'll know you did something right if these two match each other. If they match, you're doing good. If they don't match, you haven't taken enough out. The outsides become one of the bubbles, 3x minus 4, so these outside pieces become one bubble, and the bubble that matches becomes the other one. And that is your factored form. Now, what you're going to really need to do is you're going to really need to practice some of these hard ones, and I bet you that's exactly what's coming up here in just a little bit. Good job on day number 7, and the key to getting good at all this is practice. If you're not practicing this, you won't get good at it. It's like saying that you're going to be great at actually playing the piano, but if you don't play the piano, you're never going to be a great piano player. All right? Okay, sounds good. Good job, guys. Let's get to day 8 here in just a sec.